Hi everybody, this is a quick video on the calculation of percent of change. So when you hear the word change, you know that there's going to be a difference that has occurred and that will be expressed, of course, as a percent. Change is going to be the result of subtraction. So there's something that's going to be subtracted in this situation. Now, just so you know, the simplest version of how to do this is it's basically the change divided by the start. That's your formula for percent of change. If you just want to memorize that, you can absolutely just do that straight away. It's the change divided by the start. But in terms of the specifics in calculation, it's important to recognize you're going to have a starting value and you'll have a finish value. Some people prefer to think of it as original. That would be fine. Original versus final. Some people like to think of this as the old, and then it goes to the new. These are all sort of synonyms. But the bottom line is you're going to have a finished value and a starting value. Now, you don't want to get sucked into the thing and saying, I'm going to subtract the big number from the small. But what you will do is you will always do the final value or the finished value or the new value minus the starting value. And that is the difference. That is the delta. That is the change. Okay, so if we had an example, and that, of course, is divided by the start. Now, for a quick example, if someone were 10 years old and then they were 12 years old, you would say to yourself, well, what is the change here? The finished value is 12. There's 12. The starting value is 10. 12 minus 10 is going to be divided by where you started, which is 10. So 12 minus 10, 2, 2 out of 10. 2 out of 10 is also equal to 0.2 because those are 2 tenths. It's also equal to 0.20, which is 20 hundredths. Hundredths are percents, so that is 20%. Okay, so for a second example of percent of change, you might have something that goes in the other direction. So you had 12 pieces of candy. Now you ate 2, and now you have 10 pieces of candy. So you're going to be saying to yourself, well, where did I finish? I finished at 10. So calculating change, we're going to say, once again, we're going to say the finish minus the start. In this case, 10 minus 12. So 10 minus 12 is going to equal negative 2. So when we're doing the change is equal to negative 2. Where did we start? We started at 12. So don't necessarily say we started at the small number. This is a case of decrease. So it's going to be negative 2 out of 12. Now hopefully that fraction should make sense to you. 12 is the whole, and from that whole you decrease 2, you wound up at 10. So this number up here is not the 10, it's not the 12, it's the difference. It's what happened to it over time. So 10 minus 12, it decreased 2. This number right here is this beginning point. It's the reference point. It's the start. It's about where you began before this change occurred. The change is negative 2. The reference point is 12, so it's negative 2 over 12, which is also negative 1/6, which is negative 0.16 repeated, which is approximately equal to negative, well, exactly equal to negative 16 2/3%. It's important to note that you can have percent of change that is greater than 100%. So, for example, if you bought a stock, let's say, because that's something that hopefully grows for you, and you bought it for $8, and over time the stock got worth more and more money, and eventually it was worth $20. You're very happy about that, and you decide, maybe I should sell. You're trying to make that decision. Well, what would be your percent change in this case? Well, you'll simply say the same thing you have been saying. You're doing the change divided by the start. So it's going to be 20 minus 8, which will be a change of 12. Delta will be 12. 12 out of what? not out of 20. It's about where you started. So 12 out of 8. So the answer to that is, well, it's 1 1/2, or 1.5. And then what you don't want to say is, oh, well, it must be 1.5%. So hopefully your number skills will tell yourself that that would not be the case. This started at 8 and went to 20. If it had grown 100%, it would be at 16, but it's at 20. So you do the same thing you always have. If you have 1.5, math is always consistent. Boom, it's 150%. And that should make sense to you. The amount that it changed is actually 1.5 times its original value. Please note in that the amount that it changed is 1.5 times the original value. If you had the original value, 8 plus 1.5 times 8, then you get the 20. 1.5 times 8 is actually equal to 12. So in that, 8 plus 12 equals 20. That works. This relates to a very important connection you need to make later, in that if you had a problem where you had, say, some stock, and that stock was worth W dollars, you don't know what number it is, but that stock grew 150%. Well, that would be 1.5 times W, and it's added on to that whole starting value. And in the end, it was equal to 20. So if you didn't write this out, you might be tempted to say, oh, 20 divided by 1.5. You'd say the stock started at 12. That would not be the case. So distributive property in like terms says this is 1W plus 1.5W. That would be 2.5W equals 20. And when you divide by 2.5, you find out that the original price, the whole in the beginning, was equal to 8. Okay, so here are 6 fairly straightforward percent change questions. The 6th one is a little bit more of a challenge. It relates to the last example in the video. If you get stuck on any of these, please go back and just review the template about the change divided by the start and how you got there. All of these have sort of the same language. It's all about, like, where did you start? You started at 40. This is how much it changed. This is where you wound up at. So if you notice 56 and 40, they have a difference of 16. That's where the change is coming from. After that, they give you a little bit less information, and you've got to figure out the third value and therefore the percent change on yourself. The last one, of course, is a little bit of a challenge. It's similar to the last example, as I said. So 6 problems. Please show your work, and we'll talk about them in class. Thank you.